Hello, my name is Carl Schultz, and I'm from the University of Texas at Austin. I currently have the privilege of serving as the OpenHPC project lead, and I'm here today to tell you a little bit about the project, give you a brief overview, and also highlight some recent project updates. If you're not familiar with OpenHPC, I'd like to spend a few minutes giving you a brief overview. OpenHPC is a collaborative project that is organized through the Linux Foundation, and it's comprised of a collection of members from academia, industry, and national labs, and they all have a common interest in HPC software and system management. The project was initially created by a desire to have an open community effort to more efficiently build and test and deliver integrated software. This project was formalized back in June of 2016, as I said, through the Linux Foundation. In terms of membership, we have over 35 members who are participating in the community project. You can see them listed here. And I'd certainly like to acknowledge ARM, who has been an early member and supporter of the OpenHPC project. They've had active participation on our technical steering committee. And as you might suspect, they've been very instrumental in helping to contribute towards getting packages that are in OpenHPC up and running on the ARM ecosystem. Next, I'd like to highlight a couple of key takeaways for the project. And first is the idea that OpenHPC is really providing a collection of pre-built software ingredients that are common in HPC environments. So fundamentally, you can think of OpenHPC as being a software repository. And the way that we package up all of our software is to try to make it very convenient for use with standard Linux distributions that are commonly used in HPC. So in the case of a CentOS or Red Hat environment, that means that you can access OpenHPC packages directly through Yum. And because of the way that these are packaged and all of the dependencies are managed, you can just pick individual bits that are of interest for your site. So you could maybe pull down provisioners or resource managers or compilers or numerical libraries that are of interest to you, and all of the dependencies would be automatically installed. This makes it very easy to install onto a bare metal system, but it also means that it makes it easy to install into a containerized environment. And I'll show you an example of that a little bit later on. The next key takeaway that I'd like to highlight is the fact that OpenHPC is providing package builds for multiple architectures. And what we're trying to highlight here is the fact that we can install a large collection of software. In this case, we're showing in-user environment, the modules environment, which is basically all the software that might be exposed to the end user. And the point being that the environment looks exactly the same between multiple architectures. And that's really one of the key benefits that we see for OpenHPC is trying to provide a consistent development environment across multiple distros and multiple architectures. Next, I'm going to switch gears and focus on recent updates associated with the project. We recently had a big release in OpenHPC, namely version 2.0, which came out in October of this year. And with that, we are now introducing two ongoing version trees, version 1.3.x, which you see on the left, and version 2.x on the right.
The primary difference here is a function of which major Linux distro you're using. So CentOS 7 or SLES12 users would be sticking with the 1.3 branch, while CentOS 8 or OpenSUSE Leap 15 users would be using the newer 2.x version.
I mentioned that OpenHPC version 2.0 came out recently, and this table highlights all of the software components that are available in that release. And it comprises roughly 78 different software components. And the things that are highlighted in blue are items that are newish in OpenHPC 2.0. And really the big ticket item here is that this introduces support for major new distro versions. So this is what introduces support for the CentOS 8 release. And it also includes some builds against the ARM Millennia Studio compiler. I'll say a little bit more about that in a few slides. And it introduces some new transport layers, namely libfabric and UCX, and that has some impact on the MPI builds that we have. And I'll highlight fabric support here in a second. But if you add all the combinations of software that we have as part of OpenHPC, due to the fact that we build all of the third-party libraries against multiple compiler and MPI families to ensure ABI compatibility, that means today we have roughly 550 RPMs available in the OpenHPC repositories. This slide has some additional highlights of changes in 2.0 against the 1.3 series. As I've already mentioned, a big effort was to introduce support for newer distro versions, and it's probably worth mentioning that the 2.x version is not backwards compatible with 1.3, and that's really due to the fact that these are intended to be associated with fresh installs on newer distro versions. Other highlights are we've updated our InPitch build, which is an MPI software, to use a newer CH4 interface. We've made a number of software updates. So for OpenMPI, we're now building against OpenMPI 4 series. With the GCC compiler, we're at GCC 9. We've updated our Slurm builds to use the latest 20.x series. And we've actually updated our example installation recipes to take advantage of a new configless option that's available in Slurm. We have switched to doing builds against OpenPBS. That's based on a change from upstream. They've a name change associated with the open source version of PBS. And we've made various other changes that you can see here. With the introduction of 2 new transport layers in version 2.0, that does mean we have some impact on our MPI builds. As you see here, we have a table highlighting which fabrics are supported with each of the MPI builds in OpenHPC. With InPitch, we now have builds against both libfabric and UCX. Same thing is true of OpenMPI, although that's one large monolithic build. So in the case of InPitch, a system administrator can decide to install either one or both of the InPitch variants. They are designed so that both can be co-installed, and the end user can choose via the module system in OpenHPC which particular variant of InPitch they would like to use. So we see here in this slide the fact that an administrator has installed both InPitch variants and that the default in this case is UCX. One of the growing technology trends over the last few years has been the use of containers. And because of the way OpenHPC publishes our packages, it's actually fairly straightforward to pull in one or more packages from OpenHPC into a container. But one of the things we've done recently is to be a little bit more proactive in terms of providing a set of pre-built container images. So in particular, for CentOS 8, we have created some containers that can be pulled in directly using software available on CentOS 8 that doesn't require elevated credentials. And that's through the use of a new utility called Podman. Podman provides a very similar command line experience as Docker, but it doesn't require elevated credentials. So starting with 2.0, we are introducing several different container images that are highlighted here, and these are intended to provide a minimal development environment, with the idea being that you can use these as a starting point for containerizing your applications or for supporting local development work where you'd like to have an HPC stack, say, on your laptop. The 4 containers that you see here are all available in a public container registry, and those are available at the quay.io site that you see listed here. On the documentation front, one new thing I'd like to highlight is that we have recently spun up a new tutorials-oriented website, and I've got a screenshot here with the URL listed. This is a housing point for a number of different tutorials associated with the project, but most recently we've been focused on cloud-based tutorials, with the idea being that you might want to install an OpenHPC environment into a cloud-based architecture.
If this is something that is of interest to you, I'd recommend checking out our new tutorials website. There's a tutorial from PERC 20 this summer that is cloud-focused, and we also have another cloud-focused tutorial at Supercomputing.
That concludes today's talk. I've tried to provide an overview of the OpenHPC Linux Foundation project, and we've been in existence since 2016 and really appreciate ARM's support during that time. We just had a major new release, version 2.0, that came out in October of this year, and we're providing a large number of packages for use with native OS package managers, and that includes support for 2 new major distros with our 2.0 release, including CentOS 8 and Leap 15, and in both cases we have builds for multiple architectures, including AARCH64, and we also provide a significant companion test effort for our documentation recipes. And today we have roughly 10 different recipes that people can use to start from bare metal and install a working HPC cluster. Appreciate you taking the time to watch this video. I will leave you with a number of different links associated with the OpenHPC project.